Alrighty, well, we will go ahead and kick it off. Sean, you take over. Drew and I will turn our cameras and our mics off, and it's all you.
All right. And if you want, I can share my screen. I'll have to, but I don't have permission.
I can fix that. See, we should have tested that, and we didn't. All right, you should have permission now.
All right. Well, let's go with, as I'm scrolling through to make sure I have the right, I'm trying to make sure that I have the right window for it.
We see it's...
Well, I'm broadcasting from OBS.
Yeah, yeah.
It doesn't. Okay, well, what we may do then is go without the, you don't necessarily have to have my face down at the bottom right. So, okay. All right, so we have that going. All right, so my name is Sean Whitesell, and I'm the user group leader. This month actually makes 11th year that I'm the president of the .NET user group in Tulsa, Oklahoma. And I have absolutely enjoyed it. The last 11 years as president, plus the time as vice president and other positions earlier than that. So, and because of the going virtual, we actually meet twice a month now. Just because I know enough people, and I just reached out, and I'm booked through September. So we have a lot of great stuff coming up. All right, today our goal in this talk about microservices is to show that the architecture takes a lot more consideration than you may expect. And the reason why is that it may come across as easy and certainly buzzwordy, and well, to do them right and to do them well, there's a lot more to aspects to consider. Quickly, our agenda is going to be discussing what are microservices, why should you use them, and when should you not. And we'll discuss challenges, and then we'll talk about decomposition, breaking functionality out of a monolith to a microservice. But we have to do it really high level because there's so much detail in decomposition that we could spend a week, all day for a week discussing that. There's just so much going on. But we'll stay high level and we'll see what we can conquer. So usually when I give this at conferences in front of people, I ask in the audience and looking for a definition of what are microservices. And I'll get a few people that'll give me a version of a definition. And the problem is that there's not one good solid definition of microservices. There are some good ones out there, but they're not one singular definition. And instead of me trying to provide my own, I think it'd be best if I talked more about aspects of a microservice than a definition. And one of the key things about a microservice is that they are independent applications. And I will repeat that many times throughout this talk. As well, instead of code being called at a different memory location on the same computer, microservices communicate over the network. And we're going to see how that's actually more of a problem in latency and additional issues that come up. Microservices also have a single responsibility. Now, this doesn't mean one class, one method. It means one responsibility with the business functionality that it provides. If it's going to serve invoice management functionality, then it shouldn't also handle other functionality for HR or anything else. It needs to have that singular responsibility, and that's what it does and does well. As well, microservices should be owned by one development team. This allows for the evolution of that microservice to have its own requirements and deadlines, and the way it's being developed that is independent of other applications and other teams. And we're going to dive into a lot more of these as we go through here. And microservices are individually deployable. Kind of goes back to them being independent applications. Since they are independent applications, they need to be able to be deployed without a tightly coupled connection to other services or that monolith. And as well, microservices is more about an architectural style than it is coding. You can code many different ways to implement a microservice, but microservices itself is more about architecture and the design thereof. And we talk about monoliths, and they generally get a bad rap when they don't need to. A monolith is nothing more than a singular code base that has multiple independent functionalities, such as a website or a Windows applications, whatever. And they handle authentication. They've got functionality for creating invoices, to handling new employees and uh, billing management, whatever. It's just all in one code base. The problem with monoliths are when they get to be big and they become the big ball of mud. When they have spaghetti code, when it becomes more harmful with every bug fix and feature addition. And this is where we start to looking at microservices architecture. And you notice that here we've got 4 independent functionality pieces that are identified in this monolith. With microservices, generally you'll see how that functionality is either moved out of a monolith into its own microservice, or you may create a new microservice with new functionality. And rarely will you take a monolith and completely split that up so there's nothing but microservices. It has been done, and we'll discuss that, but it's rare that it happens. The microservice architecture is an implementation of distributed computing. The idea is that you're taking computational needs and distributing them across multiple servers. That way you have multiple servers sharing the load independently so that one process does not kill another, and where you might have something that's consuming a lot more resources. You can split the computational needs across multiple servers so that you're balancing out your needs. And it helps deal with latency problems and scalability. And the idea in this picture here is that there's 5 different microservices calling each other, but there's multiple instances of those 5 microservices. And the idea is that you can have as many microservices instances as you may need to serve the needs that you have. How many do you need? Well, that's going to be up to you and understanding your architectural layout and finding where those additional problems are. So why should you use a microservice? Going back to that monolith being a big ball of mud, and you've gotten to the point where every bug fix takes weeks and weeks to solve and to get out to production. A new feature, oh, that's months, because of how fragile this monolith has become. In my humble but correct opinion, microservices are best used when the time to market for a company is crucial. There are many times when a company has got a new feature and they need to get that out in the industry so that they can be the first one against their competitors. Time to market could mean a lot of monetary difference for them. And it's a big deal. But if it's much harder to change that monolith and get that new feature out the door, then another architectural pattern might be suited for this, and microservices might just be the one. Now, there are other microservices patterns out there. In fact, you've got the layered architecture, which is most people are familiar with, and you got microservices, but in fact, there are 6 other ones out there. Now, that's outside of this talk, but know that you do have many other options. And microservices have 4 main tenets. Team autonomy. With microservices, it allows you, because of the distribution of the processes across a network, it allows you to choose the best programming language for the job. Meaning that you might have everything in C#, but maybe you have a new need, and maybe Python is the best language for that job. One such example is a project that I was on where everything was done in C sharp, but the new stuff we were bringing in is for data analytics. And Python is just a better language than C sharp for data analytics. Not that C sharp can't do it, but Python's just a little bit better. As well, the data analytics people hired to bring this project together, they knew Python, so that was also the best language for the job. As well, when a singular team owns one or more microservices, then they can focus on the development needs of that microservice. It allows them to govern the requirements and those deadlines within that team instead of across many others. It also helps with the communication. And if a development team is already using Agile or Kanban, for example, then those development practices work very well with microservices. Now, with service autonomy, we're coming back to that single responsibility. A microservice should serve its purpose for a singular reason. Again, going back to the example of if it's to process invoices, then that's all it should do. It should not also handle HR requirements for a new employee or health benefits, etc. You may have another microservice that to handle those responsibilities, but where you have business domains that are clearly defined, you might be able to put that into a microservice. But also with service autonomy is that a microservice should be deployable without a tightly coupled connection to other microservices or the monolith. The idea is that if I've got one microservice and it needs to get out to production, but it has code requirements, code dependencies that another team with another microservice also has, then one deadline is not necessarily that of another. And you may even end up with breaking changes. It should be able to be deployed without the other services. Now, it might include where maybe a new feature and the new feature is calling another microservice and they need to go out together, but that's more of a feature release than it is a code development deployment. With microservices, you also get the option of scaling your instances independent of other microservices. As well, you get your choices of what kind of servers and the number of. I do a lot with Azure, so I'll just give you a quick example. Maybe I have a microservice out there and I need to spread that across four different virtual machines, but it allows me to choose the type of virtual machine that is also could be different than another microservice and its computational needs. And I understand that it might just be, virtual CPUs and RAM, but you may also have other aspects that come into play when you need to understand your choices of servers. Different servers will have different network capabilities. And depending on the volume of calls to and from your microservice, you may need to choose a different type of server. But with a microservices architecture, it allows you that option. And that's one of the greatest benefits of it. As well, there's fault isolation. Imagine where we have microservice A calling microservice B, calling microservice C, and there's some sort of a bug or some failure that occurs and it's preventing the processes from occurring. With microservices D and E, they are able to continue working outside of that fault. The idea here is, for example, is if you're visiting Amazon and the payment system goes down, should that stop customers from being able to log in or looking at other parts, other items, putting that into a cart? This allows for different business processes to continue while something else might have a failure. Now, I mentioned earlier that there are rare occasions when a microservice may start out as a monolith and is entirely broken out into microservices where there's just not a monolith anymore. These are three such companies that have accomplished it: Netflix, eBay, and Amazon. Now, they did accomplish it. They are a total microservices architecture. There's no more monolith, but it was not without the headaches. And this is what this talk is about, is they went through a lot of the pains and discovery of what works and what doesn't. What can we put into production? What needs to be reverted? How do we realign and redirect our approach? And they spent a lot of time and a lot of money to get that to the point where they're total microservices architecture. This is not easy to do. And they are good examples that, and thankfully they had the money to do it, right? Where a lot of other companies are just not going to have the money. So a lot of investment's going to have to be done in the proof of concepts to make sure this is the right direction you need to go. So when should you not use microservices? Well, to be blunt, they're hard. I know. So is good programming. To do microservices well, it takes a lot of time and money to invest and to get a lot of people on board and in the same direction. But also a lot of good programming practices are that way too. But if your monolith is just too small, where it might actually be easier on the team, the company, to just distribute the monolith to multiple servers, spread that load that way, and use maybe feature flags to govern what it's working on and what it's processing and what it's not. As well as, while your monolith may just have too much tightly coupled code, and you may just spend a lot of time refactoring. And if you have a development team that's just not willing to do microservices, or they're just not ready, they need more education and proof of concept time, then it may not be ready yet. And as well, the team that codes the microservice should also be the one that support it. If you understand how and why the code implements certain business functionality, then it doesn't make sense for some other team to support it. So you also have to have the time that you can work on new products, new features, and the bug fixes that support what's already been in production. As well, they take again, I'm pointing this out yet again, it's a high cost of time and money. So let's look at some challenges, or what some people call fallacies, about microservices. Coming back to this yet again, they're not cheap. They take a lot of time and money. You're going to spend a lot of time and money learning how to do microservices architecture. And is that the right architecture of choice? The other aspect, though, is that as developers, now we actually need to care about networking. Maybe not in great detail, but enough. Because now that we are calling a microservice across a network, now there's messaging patterns. Do you call from one endpoint to another? How do you know the IP address? Is it hard-coded? What if there's multiple instances of a single microservice? Now there's multiple IP addresses. How do you keep those in sync? Should you do a synchronous call or asynchronous? Should you use messaging like PubSub? Should you use mass transit with RabbitMQ or Azure Service Bus? Things like that. How they communicate is now a part of the picture. It's not just an in-memory call. And you may have been more familiar with, well, it's time to deploy. We just set up a job that copies files to a server. Well, you're better off with microservices to develop a continuous integration, continuous deployment pipeline per microservice. Why? Because they are independent applications. And also, because they are independent applications, they should also have their own code repository. And since we know about networking, we also need to understand two parts on the OSI model, and that's layer 4 and 7, which we're going to dig into in just a moment. And security is now an issue. You may think, well, but the microservice is not on a public network. But what kind of data is now going across the wire? What is going across that network? Did you write 100% of the code, or did you rely on something else that's third party, an NPM package or a NuGet package, for example? How do you know their code is not sniffing the network for your data and trying to send it out? It's now part of the picture that has to be understood. What if that microservice is not just invoices, but it's actually regarding medical billing, with HIPAA requirements or payment processing? What if it's handling paychecks? You don't want that information out, and you certainly don't want it to get sniffed and sent out to the public. And as well, you also need to restrict it so you understand and allow only certain callers to be able to call that microservice and leverage the business functionality in. So OAuth is mentioned as just as an example, where you're going to have to also govern who's able to call it and who cannot. Again, if it's your paycheck being looked at being processed through that microservice, do you want anybody's code to be able to call it? That'd be a bit scary. And then we look at common code, where we go that DRY, the don't repeat yourself code principle. And although that's a very good principle, you're going to see here shortly through an example where you're actually going to be duplicating code, and that's actually okay. So right quick, let's look at the OSI model for networking. I mentioned here that on layer 7 is HTTP and layer 4 is TCP. Why do we need to know this? If you look at, for example, MVC pattern, the letter they leave off that is part of it, and that's R for routing. When a routing of a request comes in, it sends it to the right controller. But that's application code that's doing and making that decision. So that's at the HTTP level, that's application level. But when you need a load balancer, so now you have multiple instances of a microservice, you have multiple IP addresses, you can put them behind a load balancer so it's aware of the IP addresses and not your calling code. Then you also split a dependency right there. So then your caller only needs to know of one endpoint, and that's of the load balancer. But since the load balancer is working with the TCP level, that's at layer 4. It's part of the architectural picture. So us developers need to understand more about networking and the different aspects to help understand how to correctly implement our microservices architecture. Now, I mentioned common code. Let's just go through a scenario here. Team A has developed microservice A. Team B has developed microservice B. And they share the same NuGet package, common code, in both of their services. Now, for this argument, we'll just say this is an internally created NuGet package. It's not a third party. Well, Team A has made changes to that NuGet package to support their changes for that microservice. And they get their microservice out the door. It's in production, that version 2. And then the next team, they also have a dependency on that NuGet package, but they can't get their version out because of the now breaking change. So if they change it back, well, then that's going to hurt Team A for version 3, and etc. There's going to be this ping pong effect. Well, there's different problems here. One of which is this absolutely does require the teams to communicate. Not a bad problem anyway, but they should be communicating anyway. But they shouldn't have to communicate about code dependencies that can hurt each other's deadlines. So what do we do about this? I understand we've grown up with the do not repeat yourself code principle. But even outside of microservices, if you look at domain-driven design, it too will tell you that at a point, you do need to duplicate code. The idea is that if you were to make a NuGet package of that duplicate code for each of the microservices, then it's actually not duplicated for long, because then the NuGet package for microservice A can evolve independently than that for service B. It may seem like it's duplicated at first, but it will quickly evolve and actually not be identical very, very long. This allows the microservices to evolve independent than the others. Since they are independent applications, they need to be able to evolve without tightly coupled connections to other services. So the principle here is to separate the code that changes to their own package for the service that needs it. This way, again, just to reiterate, this allows the independent applications to evolve independently. Let me ask you a quick question, though. Back on this slide, we have this common code in the middle, but it's not gone. It's still there. Well, this is where you might separate code that needs to change, and maybe you didn't separate everything. Maybe it's still common for a while. Is it tightly coupled? It's coupled, but how tightly, that's up to you between the two different teams and the two different microservices. It might quickly be the next version that says there's even more to split apart. That's just part of the evolution. But that NuGet package foo right there in the middle, which team owns it? That's part of another problem. If not a single team owns it, but a collection of teams owns that common package, then you have the ability for challenges of requirements and deadlines on that code. That could be a sore spot as well. All right, so you're still convinced that you need to go ahead and make a microservice, so you jump in and you start pulling functionality out of your monolith into your new microservice. Then you realize, well, it has another dependency. All right, so you pull more code over, but it too has another dependency, and you start bringing that over. Then you realize you don't have another microservice, you have another monolith, a distributed monolith model now. Now, this could be okay, and this can also be bad. My suggestion here is that if you are truly heading towards a microservices architecture, you do not want to stay here in this distributed monolith mode. Now, if you do go to production with this and it buys you time to further split that second monolith to microservices correctly, then fine. It's simply a hop on the road. It buys you some time to get there to a better architecture implemented. However, if this is your end state, you're probably not going to like this. Now you've got more problems than you had before. So now we're going to shift gears again, because we also have another problem with the microservices architecture. And that's where we need to decentralize our data. When I was first learning about this, I didn't agree with this. I thought this is ridiculous. If you've got a single database and that's where all of your data is at, why should a microservice that's dealing with invoices, for example, have to have its own database? When I understood why, it makes complete sense. Because just like at our code level, we can have a tightly coupled dependency, we can also have a tightly coupled dependency at the data level. So let's go through an example. Imagine we have a monolith and it has a singular database, and it's got tables for accounts, customers, orders, orders history, parts, parts one, shipping history, and logging. But wait, parts one? Well, yeah, because as they all do, table schemas grow and change. And at some point, the parts table has grown into something that they could not do in the same table. So they had to create another parts table. And of course, since naming is hard, parts one became the name. So let's stay with this parts bit for a little bit. So now imagine we have a parts microservice and its database, and an orders microservice with its database, and then a shipping microservice with its database. And you see that there's dependencies on the data. Shipping needs to know about orders, and orders needs to know about parts. So the rule here is that if a microservice needs to persist its data, then it needs to have its own microservice. So let's dig in and we'll discuss how we're going to handle this when shipping needs to know about orders and orders needs to know about parts. We could do this right here, where if the shipping microservice needs information about an order, it can just call the order microservice. And if orders needs to know information about parts, it can call the parts microservice. This is okay. However, you may also notice that the network calls become chatty. It's chatty enough that things need to change, because now with all the network calls, depending on the volume of network calls, you may risk port exhaustion or additional latency. So at some point, it makes more sense to duplicate data. Just like we were duplicating code earlier for the context that they need, so we also need to apply the same principles to data. Let's dig in even further. Looking at the parts microservice, imagine a database that's retaining information about parts. It has the ID, a natural key, part number, part name, etc. We all these details about a part. We also have manufacturer name, the manufacturer's part number. When was it manufactured? What part number does this part replace? When was it discontinued? So it is the single source of truth for everything about parts. Anytime that another system needs to know about parts, it can come to this parts microservice and grab that information. Or it can duplicate some. As we look in our orders microservice here we've chosen that its parts table in its database is going to have some of the information about parts. So some of that information is duplicated. But you notice that it only has enough information about parts that it needs to do its job. An order really doesn't need to know when was it discontinued. It doesn't need to know about manufacturer. So there's a lot of other information about the parts that don't have to be duplicated. And this allows for business processes to continue existing without network calls that are not needed, where it might be more efficient to just duplicate enough data to fulfill fix the problems. So up till now, we've got a microservice or a monolith calling a microservice, and we're calling across the network. Now, we can continue doing this, but a big question comes up between the single source of truth and other microservices holding some of that duplicated data. What if there's a difference in data? What if the parts database got a typo fixed? How does the orders microservice have that data kept in sync. This is where we may change our communication style to messaging. So here, the idea is using a message bus and different types of messages, then the monolith and the microservices can communicate with each other without having tightly coupled connections. Because just like HTTP is not specific to programming language, the messages are also not specific to the microservices. They just contain the information they need for that message. And then it's up to the receivers to react how they need to on those messages. So in this case, let's pretend that in our monolith, it's a website and that the administrator has noticed that a part number has a typo. A part name has a typo. So the administrator goes in and updates the part name, and a message is sent, and where the parts microservice picks up that message and updates the record in that database. And then the order microservice says, well, I might actually have that part, so I'll react on that message as well. It searches its database for everywhere that part name has been leveraged, and it updates accordingly. I'm just giving an example, but the idea is that the microservices can react independently, because they are independent applications, to a message that says, we have a typo that got fixed. Now, maybe that administrator also adds a brand new part to the system. So a different type of message is sent out. Well, the order microservice doesn't need to know about a new part. It cares about orders with existing parts. Shipping doesn't need to know that. So the parts microservice reacts to that message and says, okay, great, I will add that information to my database. And when an order comes in against that part, then that data might be sent over to that order database, depending on how you've set this up. So now messaging can also help out in a different way. Imagine that we have a website and it's for selling products, and there's an order that comes in through the website. So the order microservice is notified and a new order is created. The payment microservice is reacting to that message and is trying to process a payment, and inventory is reacting to it as well. And it says, okay, fine, we're going to take that product off the shelf and get it ready for shipping. So a saga is a type of message that can help keep things in order, and that microservices are reacting as they need to for the different types of messages. As well, in this case, we can say, what if a payment fails? Let me give you a real world example. Now, I use Amazon just like a lot of other people, but something I personally do is I have a different checking account set up with my bank that I use explicitly for internet purchases. So I'll maybe put in maybe $200 into that account. So if it's ever hacked with purchases over the internet, then the most they're going to get is maybe that $200, right? They don't have access to the checking account where my paycheck lands. Of course not. So, but sometimes, as it happens, maybe I'll buy something off Amazon and then I forget about the balance. So I make another order, and an order is created, and I get an email that's from Amazon. It says, thank you for your order. We're going to get that shipped out to you as soon as possible. And a few minutes later, they send another email that says, well, there's actually a problem. There's, not enough funds. You get that fixed, we'll get this shipment right on the way, right? So what you can do with this is that with that type of message called a saga, if there's a failure, it can tell the other microservices to process your undo steps. So where inventory may say, oh, well, It's not going to be shipped after all for right now. So, all right, we're going to put that inventory back on the shelf. And order picks up that message and says, well, I'm not going to delete the order because we don't delete data. That's bad. Instead, we'll change the status. Maybe we'll change the status to payment pending. And then when the correction comes in from the customer and they update their payment and says, try it again, well, then there's another message sent out that says, oh, let's try that again. Well, the order's already created, so we're going to use the existing order number. And payment has succeeded. All right, great. Now we're going to pull it back off the shelf and get that boxed up and on its way. The idea is that microservices that are independent applications can communicate with each other just by messages and not have code requirements or data requirements with each other. All right, shifting gears one more time. Now we're going to get into decomposing a monolith to microservices. And again, I have to keep this high level because I'm going to talk a little bit about domain-driven design and decomposition, which are very deep subjects. And we really could be talking all day and take up at least a week on this. So I do need to keep it high level as best I can. So you remember how we were talking about looking at functionality inside of a monolith, and we're going to extract that out to a microservice. This is decomposition. Now, I don't know about you, but I don't know that I've ever worked on a project where the boundaries of the different domains in a monolith were as clearly defined as they are in this image. Most of the time, it's more like this, where those boundaries between the different types of business functionality are not clearly defined. And you may have to spend some time, fixing this up, refactoring, and bringing in good dependency injection to help break the tight coupling. So how should we get started? Well, my suggestion is to start small. Because microservices are independent applications, you're going to need time to build the infrastructure and to learn how to do this, even with the smallest bit of code in that microservice. Now that you have your independent applications, you need to set up that CI/CD pipeline. It needs to have its own code repository. Why? Because as an independent application, it also needs to have its own requirements and deadlines that are separate than others. Because it's an independent application, you want them to be able to evolve independent of other items that you may have on your plate with other applications. So you're going to spend time learning how to build and setting up your processes. So starting out with a small piece of code allows you to build small and build out your infrastructure and test out a few things and get things ready so that you can build on and get to bigger microservices. So let's take an example here. I have this company called Wham Bam, and they're a production company, and they make fidget widgets. Now, I'm going to mention the use of domain-driven design, but that's not the only way to do microservices or to even decomposition. It lends really well to doing decomposition, but it's certainly not the only way. And with domain-driven design, we can look at this production company. Notice that the main domain is that it is a production company. It's not a software development company. It's not a hospital. It's not a hotel, for example. They're a production company. But they also have adjacent domains that help that main domain exist. So we can also see that there's purchasing and shipping. I know they may look like departments, but this is more about the code that implements the functionality that you may see in different departments. And since we are talking about departments and we are talking about understanding existing code, Something that I highly recommend is what's called event storming. Let me touch on that for just a moment. Imagine, if you will, that you're at your company and the development team, are working with subject matter experts called domain experts about how they do their job. How does purchasing actually purchase raw materials? How does it keep track of that? How does production take raw materials and end up with a product that we need to ship? How does shipping understand that the final product and understand how it is it to be packaged? Do we need a flatbed truck? How do we schedule that? With event storming, you are working with those domain experts, those subject matter experts, and you've got a big piece of paper going across the wall. Imagine maybe in a hallway, for example, and you got a lot of post-it notes or sticky notes, and you're writing different things on the different colors, because this is more of a color dependent activity, where different colors mean different things. And by this process, this workshop, if you will, you're able to understand the business functionality that is occurring at the different domains. So that while you're digging in and understanding how does a piece of paper become an invoice and how is it processed through all the different phases, then you're better understanding the code that was written to implement that business process. This is also really great when you have maybe a change of developers on a team or a new developer on a team. So I highly recommend looking into event storming. It's not part of domain-driven design, but it is about domains. All right, so we're looking at our production company. We have these 3 domains, but there's actually other domains, and these are, to a lesser extent, where maybe, like, for example, accounting, invoicing, and returns, return management, those could be replaced. That code could be replaced with something off the shelf. Maybe it's a package that's purchased by another company and not internally written. But the idea is that you can see the different domains and you can see the interactions between the domains. All right, so now we're going to dig in even further. Now we're going to look at the 2 domains, that's purchasing and production. So as we've gone through our event storming and we're looking at the different code pieces, the activities that go on with purchasing and how they have a relationship with vendors to purchase raw material, and that raw material is what they call parts. And as well, you see in the production domain that, well, they've got parts as well, and they're tied to orders, because that way they know why they're building things. And then they have the final products that is to be shipped out. And we notice something through this process, that we have parts and we have parts. This is kind of a bad thing. So with domain-driven design, there's a thing called the ubiquitous language. And if we were to change names so that they are context specific, then this helps alleviate some ambiguity of things. And it's highly suggested, and I certainly agree with this, that when you change the names of things, that you are also changing it at the namespace, the class names, and even method names of the code that is implementing these different pieces. Then if you have a new developer on their team, or maybe it's you 6 months from now and you're looking at this code, you're able to quickly pick up and understand the context and more of the reason why the code does what it does and how it relates. So the ubiquitous language is actually considered one of the main tenets of domain-driven design. Okay, so now we're going to dig even further. Now we see the difference between purchased parts, that's the raw material, and then we have assembly parts, and then a developer says, wait a minute, well, what's the difference between a purchased part and an assembly part? Well, that's a great question, because maybe in our example, they're not the same thing. Purchased parts is maybe the nuts and bolts, and it's just the raw material where the final product that our company is shipping out is actually made of other parts that are pre-assembled out of the raw material. So there's actually a step in there where they're assembling parts, not for sale, but for the bigger picture, the bigger product. So again, by changing the name, we're able to see how it better fits in the business functionality. All right, we're going to stay in the production. Well, I'm sorry. I forgot to mention this right quick. So as you're noticing the different code pieces on the wall, and I say code, it's more of the business processes, you're able to see how things go together and what do not. And imagine drawing a circle around those pieces, and you see what is become context. Purchasing and production, I said they're domains, that's just true, but they're also considered bounded context. This is a domain-driven design term. And this is where, because a domain could actually have more than one bounded context in this case. But you were able to draw that circle around the pieces that belong together, work together, but are not with other items. And so where purchasing has a relationship to product only because production is requiring those products to be purchased, but it doesn't care how it got there. And purchasing is more involved with purchasing products or parts for the raw products, but it doesn't necessarily care of how it's being produced. So you can see where pieces that stay together versus the parts that are not. Okay, so now we're looking at what inside the production bounded context. Now we're at the code level. Now we're looking at classes and objects. And this is when you see this code and you see what there's dependencies, like we have an order class that has a dependency because it's made up of order lines. And we see products that are made up of assembly parts. Well, these are what's called aggregates. And this relationship is built up so that you see in this example, two different aggregates, and the order and the product are two different aggregate roots. Eric Evans, who created domain-driven design, has a rule that any calls into an aggregate must go through the aggregate root. The call can come from any of the code inside of an aggregate. Maybe there's functionality in an order line that needs details about an assembly part. But to do that, it has to go through, and that functionality has to be there at the product aggregate root. The reason for this is it helps keep data integrity. What if that function in order line was calling a method over in assembly parts? It could change details that the product class was not aware of. Then you risk that data integrity. All right, so now we're looking at our aggregates, and we kind of see that there's functionality provided by order and provided by product. So we think, well, maybe this is a good area for having a microservice, a production microservice. And again, I say possible service because this doesn't have to be a microservice. Maybe it's not on the network at all. Maybe it's just a service that's provided in a monolith. This is, so far, it's just been good use of domain-driven design. And then I list out some possible functionality that's exposed of the microservice. And again, you notice that it's multiple classes, multiple aggregates, but it's one bounded context and it's one microservice. Now, with this bounded context, it actually is possible that you could have more than one bounded context in a microservice. It just depends on what functionality you need to have exposed across the network for other callers. And by having bounded context, you're able to keep things separate Therefore, you have your context-specific differences in your code and not have tightly coupled areas. Now, although I said that a microservice can have one or more bounded context, you will not see a bounded context that exists across different or multiple microservices, because that would make them tightly coupled. And who's to say that a one team owns both microservices? Maybe they do, but that it may not always be the case. When you have a bounded context shared between microservices, it makes them tightly coupled. Now, this is with business logic, though, company-specific business logic. There is an exception to this. If you have a bounded context that is for cross-cutting concerns, then that can be shared across multiple microservices. Well, what are cross-cutting concerns? Well, imagine that you've got your development team that's been working on the monolith and now microservices. And maybe there's one development team, maybe there's multiple development teams. But maybe you've already decided on how you're going to handle logging and monitoring. And you don't necessarily need new logging for every different microservice. Maybe they're not company-specific business logic, but instead it's more generic. That code can be shared across different microservices because they're not context-specific business logic. Instead, it's how things get logged. How is monitoring happening? Just to name a couple of examples. Okay, so like I said, that was high level, and we went from looking at a existing code in our monolith and better understanding it, talking it over with our domain experts, and we started to understand the code in our domain. And we even got so far to understand our aggregate roots, what things we might need to refactor. And we're able to build out our bounded context and identify what might be good microservice. Of course, identifying microservices, there's a lot more to it. How to decompose things, yep, there's a lot more to it. But this is a quick high-level overview about decomposition. So it's about time to wrap up. So let's do a quick review. Microservices are hard, so is good programming. It takes a lot of time and effort to investment into doing them right. Sometimes you may put out a microservice to production and have to pull it. You may have to take a step backwards just to realign and take a different approach. And that's what happened to Netflix, eBay, and Amazon. They tried things and pulled it back and tried it different ways. You know, you're going to have to learn about how microservices should be called. You may start out with an RPC style, that remote procedure call style, only to realize that that's not really a good implementation. Maybe switch to messaging. And you still need to build out your CI/CD pipeline and your code repositories per microservice. Why? Because they are independent applications. And you see how sharing code creates tightly coupled services, where you're going to find that as it pertains to bounded contexts at the domain-driven design level and with microservices, sharing code or duplicating code might just be okay because it allows them to evolve independent of each other. And as developers, we need to know more about networking, the difference between layer 4 for load balancers and layer 7 for application layer, and how things are decided and worked with at those different layers. We also need to understand about securing that information that's in the calls to and from a microservice. You may look at something like Istio, for example, that builds a sidecar, which is another type of pattern. And it helps to, by intervening, it brings in the ability to encrypt that data. We might also need to bring in something like OAuth, and this is just an example, so that we're able to secure our microservice as to who can call it. And microservices have team autonomy. It allows for a single team to be responsible for one or more microservices. That way they can control the requirements and the deadlines. And since it's independent application, help control the application lifecycle management of it. And with service autonomy, you don't want to have a service that's tightly coupled with another. Else, every time you deploy a service, you're waiting on the one that's behind, and it could hurt a deadline. As well, microservices can provide you the opportunity for scaling your microservices independently and different than what you may be using with other microservices or the monolith. As well, microservices provide fault isolation. That way, if a business process fails at some point, it allows for other business processes to continue. And then we also looked at domain-driven design, a real quick high-level overview of it. And we understand that there's things called bounded context, the things that operate together but are separate from other contexts, and how because of this code and how it works together, we can draw our circles around it and understand our dependencies around that. That way we're able to build what we call a bounded context. And inside our bounded context, we have our aggregates, our set of classes where they have maybe a dependency on other classes. Maybe it's inheritance, maybe it's composition. But you're able to see those aggregates and how that relationship that is there. And then that for data integrity, you need to have code calls that are going through the aggregate root, that top level class. And if functionality is not there, then needs to be by another aggregate, or even at another microservice trying to make a call in, well, then it's up to you as the developers to maybe add functionality at that aggregate root to provide that functionality for the caller. Now, with this screen right here, you're going to want to take a screenshot of this. And I say that because I've had multiple people request this. There's some recommendations that I have, and that's Microservices Patterns book, Domain-Driven Design, but of course, Eric Evans, who created Domain-Driven Design, and Patterns, Principles, and Practices of Domain-Driven Design. That's PPP of DDD by Scott Millett and Nick Toon. And the reason I like the Patterns, Principles, and Practices of Domain-Driven Design book is because it provided a different way of explaining domain-driven design, and it clicked for me. So by having additional resources, even about microservices, or just as we do with code, as we have different people explaining different things, some things will click different for people, and different people get it in different ways. All right, so that's enough about me, and I appreciate any questions and any feedback. My name is Sean Whitesell, president of the .NET User Group. I'm a recent MVP with Microsoft. I'm an ASP Insider. I'm a cloud architect at TokenEx, and there's the link to my user group. And a quick shout out to 2 other Twitch friends that I have, Developers Garage and Tail Learn Code. So with that, what questions do you have?
Alrighty, chat. Bring it on. So there was one question, not really a question, but more of a discussion point a little bit earlier on. Were your thoughts on the transactional outbox pattern for microservices? Do you have any experience with that?
So I can tell you that doing distributed transactions is another topic for another talk. I actually, so I've got a friend of mine that would do a far better job of talking on that than I can do, because if I was to give an answer right now, it's a high likelihood I would be wrong. But I can get you a resource to help better answer that.
All righty. Getting a couple thanks from the chat. This was really good. We were commenting earlier. Our good friend Sydney Azure Sharp was saying that. What was he saying? He was saying good things. I promise. They're really useful. You're covering stuff that doesn't normally come up in microservices talks at all, and they're issues that you'll run into when you run into them. And so very, very good. Let's see.
Well, good. And that's kind of the premise of this talk, and hence the title, right? The easy way is the wrong way. Is you may want to jump into doing them, but this talk, and I guess the reason that this talk has actually done really well for me, is it talks about things that you're going to need to know before you just jump in.
Yeah.
And if you really want to go swimming at the Olympic level, here's the training you got to know to get there. And I'm not the one defining expert on everything to do with microservices, but it's the idea is that here's a lot of things to think about as you jump in.
Yeah.
And so,
and it's like you just said, there are 3 books on the topic, and you can't cover even one book in 60 minutes.
And I can also say that with Codepalooza, I believe there's a whole track's worth on on 1 or 2 days, I'm not sure, on microservices. And so I'll be giving this talk there at Codepalooza, but there's going to be other talks on microservices, and that just shows you how complicated they really are when multiple people giving multiple talks about them.
We have a question from Surly
Sure.
Dev. I don't know if you have the chat up, but he was asking, you talk about messages going along with the message bus and a, quote, corrective action saga being sent out if a process fails, like payments, for other processes or services to roll back. In my mind, each microservice would send a success, and the next one would pick up on that. Why roll back and not roll forward?
Think of it as the one direction is a happy path where an order is created and payment has been processed, and then inventory has picked the product, shipped it, and process 1, 2, 3, right? And if something happens along the way, it might be, in my example, quick example, it was a payment failed, which is an external force. But what if it was a code bug level, and where it hit an exception and it cannot continue doing its job? Then that microservice is in a sense failing to even do a success message, right? And so it's failing to do its job. Therefore, it has to send back and say, I can't continue. I'm failed. So it allows that the previous microservices that were called to have the opportunity to process their undo steps, and they're able to independently implement what that would look like. How do we revert? Do we even revert at all? In my example, we don't want to delete an order. We want to change the state of an order. And that way, in that sense, we're not deleting data. So you do want the ability to roll back, so that just because they, in a sense, they are distributed transactions in and of themselves. If this was a monolith in a singular database, then you're going to create the order record, and you're going to get things, then send out things for payment. And if there was a bug in that, you'd still have the same, well, what do we do now type of business process.
Gotcha. Mill D asks, can you speak briefly on the applications of CQRS and the possibility, the applications of non-relational databases within this pattern?
And yet stay brief.
Yeah.
So the quick thing is, no, I can't. Not and stay brief. Now, with decentralizing your data, that by itself, you're able to, and I should have brought that into this talk, but as you're able to choose different programming languages for different microservices, when you decentralize your data and you have different databases, then of course you can choose different types of database to house that data. that's specific to or better for your needs. Most likely, and I say that generically, that if you're going to start out with a giant SQL Server database or an Oracle database, and both relational, right, then and you split out that data, you're more likely to keep the relationships, tables among tables, and keep it relational. It, you still have the opportunity to go from a relational to a non-relational. I mean, you can grab, or even create a brand new microservice and use Cosmos DB, for example, or Mongo and things like that. But yes, it allows you the opportunity, but CQRS is going to be kind of a deeper topic, though.
I feel like there's a whole books written on that topic.
Yeah, yeah.
Drew, I'm going to let you ask your own question.
This is more of a comment than a question, but thought you might have something to discuss on this. You hinted at this a bit when you were describing domain-driven design, but I've heard that many applications would gain some benefit from refactoring a monolith down into individual components without breaking it into microservices, or gain more benefit from the refactoring than the breaking apart.
Absolutely. And it may stay as a monolith, but when those components, which you can also call them services inside of a monolith, they're just not exposed on a network, then you still absolutely benefit from something like domain-driven design, where you still have that separation and the breaking down of tightly coupled dependencies at the code level. And then you're also able to duplicate code where it makes sense to in different bounded context. So even that what was duplicate and identical is now not identical, but evolved specific to the context that it's in. And absolutely, even microservices set aside, and I mentioned this earlier, is that there's other architectural patterns out there that might be better suited than microservices. Absolutely. And microservices, and I won't say it's on the extreme end, but it's a architectural style that takes a lot of effort to do them well. But there's other ones out there, so you might dig into. And checking my notes right quick because I had that written down. Oh yeah, okay. So you might look at modular monolith or microkernel architecture, service-based architecture, or service-oriented architecture. And yes, microservices is a type of service-oriented architecture. The biggest difference is that with the messaging, where's the business logic that handles the messages? With service-oriented architecture, you found a lot of the business logic in the pipeline itself. That, things like BizTalk, for example, was really big on that. It had, a lot of business logic at that layer, where microservices, it allows for the messaging pipeline to be dumb, as I think it was Martin Fowler or Sam Newman. I don't remember exactly who said this, but you want dumb pipeline and smart endpoints. So it's kind of a shift of responsibility of the messaging in that architecture between service-oriented architecture and microservices. As well, there's event-driven architecture and space-based architecture. And the guy, or actually two guys that can talk a great deal on this, and I highly recommend anything by these guys, is Mark Richards and Neil Ford. And they've got a book out on all 8 of these architectural styles, and where they've co-authored that book together by O'Reilly. So I highly recommend that book. I should add that on here as well. So, but yeah, to your point, that when you refactor to cleaner code, whether or not you go to microservices at all, you can benefit a lot by clean code and domain-driven design.
Thank you.
All right, so chat's gone kind of quiet, so we'll go ahead and wrap it up here. Sean, thanks so much for. Oh, wait, we just had a last minute question come in.
Okay.
All right, question. While there's still a concern for security using microservices, is there a security gain by, say, pushing database calls or connections off of a server sitting in a DMZ?
Ooh, okay. Let me think on that one.
Oh, the hard questions always come in last, right?
Well, right.
The thought-provoking ones.
So regardless that they are networking calls, should you have them in a DMZ? And I would almost say no, because your public facing services, they can be exposed in the DMZ, but if you're calling a microservice that actually exists more of for the purpose of a back-end process, then that's going to be a more internal network call and not in a DMZ. So this also allows you, and as I've done them before by using different subnets, I can use different network security groups that helps control the north, south, and east-west traffic. And the idea that north and south is inbound and outbound to the public, where east and west and maybe server to server calls. So I won't say DMZ. Leave that for what needs to be public facing.
Good times. All righty. Anyone else? Going
Good
once.
questions. Good questions.
Going twice. Alrighty, so I think we're good to go.
Okay.
Thank you everyone for hanging out with us today. Thanks Sean for such a great session. We have one lined up for next month. I don't remember who it is. Drew, do you remember off the top of your head who we have next month?
I do not, but give me
not
a
a
second.
problem.
I can look up.
That's all right. Don't worry about it. So if you're not following, hit follow. You'll find out about us later. Sean, again, thank you so much. We're going to do a raid. Sean, is there anyone in particular you want to raid?
Oh, let's see. It looks
I was
like
leaning towards CLW.
CLW is on there, Corey.
Yeah.
But he's been on there. I don't know how long he's actually been on.
He's been on for like 3, almost 4 hours now. He's just going.
Yeah.
Oh, he might be wrapping up because he's on his I'm just talking to people stream. Brian Robinson just went live.
Or Callow Creation or Master.
See, Creation's playing Modern Warfare, so I don't want to.
Yeah. There's Microsoft developer.
Lana she's always streaming. She's probably like in her 8th hour right now.
Microsoft developer is on.
Are they? You know what? I'm going to do Brian Robinson because he is.
All right. I don't know him.
Robinson.
And thanks for having me. This was great. I really appreciate being able to talk to your group.
Hey, we loved having you. So, all right, everyone, hang on. Hold on. Let me make sure he's actually streaming.
Oh, you got
said
Azure
he went
Notebook
live.
Adventures.
What's that?
Azure Notebook Adventures with Sarah Suduki. That's a good talk.
Yes. All right. Is Suduki streaming? Oh no, that's right. Suduki's here. I was watching Suduki last month on the Dev Talk show, and she did a great job. All right, Brian L. Robinson. I got his name wrong. All right. So next month we have Suduki. We are going to go raid Brian Robinson because why not? All right. Take care, everyone. We'll see you next time.